All right, everyone, we'll go ahead and get started here. So my name is Travis Stafford. I'm here with Jeff Jarmuck. We are both on the Salesforce.com product security team. And today we're going to talk to you about how to avoid common security mistakes when you're developing for the Force.com platform. So forward-looking statement, which of course got mangled again. Well, pretend you can read this. Forward-looking statement, please don't make any investment decisions based on the content that we're delivering here today. That's about it. So throughout the week, we've had a number of great security sessions here at Dreamforce. This is just one of them. We have also a great security booth over by the big tree in the developer forest where people from the security team, such as Jeff and myself, have been all week answering questions about security. We also have a security booth over here in the admin zone. So if you want to get some coffee, learn about how two-factor auth works, it's a great place to stop by, get some coffee, and learn how to configure your Salesforce instance. So Friday, we have two talks. Quick security fixes with the Force.com scanner should be a great talk if you want to learn about static analysis in your Salesforce org. And two-factor auth, what is it and why do you want it? So if you get a chance, please stop by those talks. They should be fantastic. So security in the Salesforce App Cloud. So the App Cloud is designed to be powerful and flexible. So we have all this great sales data, this marketing data that you've been running your business with, but maybe you want to do more than what we can do with the basic vanilla Salesforce, so you want to write custom integrations, do interesting and powerful things with that data. So we want to create a platform that allows you to do everything that you want to do with that data, but also keeps you as secure as possible. So we have a number of built-in protections on the platform, and in addition to that, any app that you download off the App Exchange has gone through a thorough security review by the folks on our team at Salesforce. We've tested the code there and any external integrations to make sure that they're secure before it gets listed on the App Exchange. So we have a big culture of security at Salesforce, and we want to make sure that the apps that get developed and touch all of that great data that we have are as secure as possible. So during the App Exchange security review process, what vulnerabilities do we typically see? This is actually out of our tool that we use for reviewing the App Exchange applications, and these are the actual top vulnerabilities we see. Today, we're going to be talking specifically about cross-site scripting, which is the #1 vulnerability that we see throughout all of our App Exchange submissions, and SOQL injection, which is a bit less common, but is nonetheless a very dangerous vulnerability to have in your code. So we'll start with cross-site scripting. So what is cross-site scripting, also known as XSS? Basically, the vulnerability comes about from mixing code and data. Theoretically, we want to have a separation between the code that we've written as developers and the data that we want to supply, such as accounts, any objects in the system, things like that. There should be a clear separation, but the problem arises when you attempt to mix those together in code. So typically, for cross-site scripting, that means a user can supply input that gets displayed onto the page that is shown to the user. So this could be any way that they input it, from a URL parameter to a text box, basically any way that users can supply data that reaches the page itself. An attacker using this vulnerability would basically try to steal session information and then impersonate the user of the application. So they can run JavaScript as that user, steal their session ID, send it off to some third-party site, and then later they can grab that, come back in, and imitate that user on Salesforce. So they'd have access to all the data that that user would have access to and can perform any actions in Salesforce as though they were that user. So they can call functions in the DOM as well with the JavaScript. So what does that look like? So here we have kind of a dummy HTML page. It's kind of a hello world page. So we have a merge field here, and this could be using whatever framework you like, jQuery. If you're writing Salesforce, we have merge fields built in Apex and Visual Force. So user supplies their name. We want to greet them once they log in. So under a normal situation, that would just be your username. But if we're taking this input from the user themselves, let's say we let them set their username to whatever they want it to be, they could set it to something like this. So now we have a script block being injected into the DOM of the web page, and the browser doesn't know that this data was sent by the user. If I'm just looking at this page right here, I see a body tag, and then I see a script tag. Oh, it's time to run JavaScript. And then we can carry out a transaction. In this case, it could be a bank transaction. It could be custom JavaScript to exfiltrate the session ID. But the point is that we're executing code, and it looks like it's code that was written by Salesforce or by you as the developer who is serving up the code. So what does that look like in real life? So here we have the security trailhead that we just released this week. We've been talking about it all week, and if you want to see more demos, we have them set up there at the security booth that we mentioned earlier. So this is our cross-site scripting demo. Here we have a feature where we want the user to be able to type something and then have it show up on the scroll. Hello world, look at that. What a fantastic feature this is.
Thank you. It's a very featureful app.
So when I see something like this, I see user input. It's also up here in a URL parameter getting sent to the page. So I think, let's see if we can put something a little bit malicious in there, some HTML code, for example. Boom. So now this page was coded insecurely and allowed a user to provide their own input here. And then it got sent to the page. And this pop-up box is showing us that we got JavaScript to run, and the browser can't tell who ran it. It looks like our Visualforce page is the one that served up that code and did something that wasn't intended by the developer. So we'll go into how to fix that in just a second. So App Cloud XSS protections, what not to do. So these are kind of the main anti-patterns when you're developing code that you want to never do because they're almost always insecure. The first example is actually what we have in that demo, which I'll show you in a moment. Getting a document.getElement by ID will get you a handle to an object in the DOM, and then we're setting its inner HTML value to something provided by the user. So we're taking some raw value that we haven't done anything to, sticking it straight into the DOM and treating it like HTML. So you can do this safely, but it's very difficult, and we generally don't recommend to do that. Another way that you can shoot yourself in the foot is if you intentionally add an unescaped HTML attribute to your Aura tags. That will intentionally not escape the data that you're putting into that tag. So it can be very dangerous if you haven't been very careful about what you've put into that tag. So better safe than sorry. Try to avoid these if at all possible. And if you definitely think you need to use these, reach out to the product security team at Salesforce or to your own security team if you have one. So XSS protections that we have built into the platform. So if you're writing a Visualforce page and you want to put a merge field into HTML, it's going to be safe by default. We HTML encode merge fields by default, so you don't need to worry about that. In Apex, you can have an Apex output text field, and this will also always automatically escape for you. You don't need to do anything additional to make sure that you're going to be safe here. If you're writing custom JavaScript and you want to use user values that have been provided in the JavaScript itself. Here's an example where we're trying to set a variable to something supplied by the user. So we need to JS encode that because in this case, we're in a JavaScript context, and depending on where the variable is being inserted into the page, there are different special characters for that context. So JavaScript, things like single quotes and semicolons are special characters. If you're in HTML, things that make up HTML tags, such as less than and greater than, are special characters. So depending on the context that you're in, you need to be aware of which encoding you're going to be using. In this case, we're in a JavaScript context. In order to make sure that we don't escape from this quoted variable declaration, we need to JavaScript encode that variable. And again, this is the demo that we have that we're going to go back to in a moment. Setting inner HTML, because we're in JavaScript while we're setting this value, we need to first JavaScript encode it, so we can't break out of this declaration here. And then we're also assigning it to inner HTML, so we need to HTML encode that value once it gets to the page. So I mentioned earlier we rarely recommend doing inner HTML because it's difficult to get correct. This is how you do it right. But in general, we recommend avoiding this because it can be very tricky. So for the mitigations, let's go back to our page and see if we can fix it. So if you look at our Visualforce page, here we can see we're getting document.getElement by ID, getting our text output component, and setting its inner HTML value. Here we're setting the scroll, setting some CSS, etc. And then finally, we're appending our output text value that was sent to us by the user. And it's going inside of an I tag, so that's how we italicize the font. And we got our beautiful scroll to render. So how can we make this safe to cross-site scripting? So to show you why it's difficult, if we just HTML encode this, we can see here, this is what we wanted the app to behave like in the first place. We got the text that we typed in correctly rendered in the HTML context of the page. It looks great in the scroll. But we're not totally secure because, remember, the different contexts have different special characters. We've encoded our HTML special characters, but we haven't encoded yet our JavaScript special characters. So here, I'm inserting some JavaScript that will look nice inside the way that we've configured it here. So if I put a single quote here, I'm ending this inner HTML call. A semicolon will end that declaration. Then we start more code that I'm writing. And then since we had that string with a bunch of extra junk on the end, I'm writing another declaration that will keep it well-formed JavaScript. Oop. And of course, it's not working. Demo gods are evil. But in general, JS and HTML encode will work for you in this case. And I apologize for my demo here not working, but imagine that that rendered JavaScript as well. All right, so when you're testing for XSS, what do we do and what we recommend for how you test it? So if you have a black box application, and this is what we call an application where you don't have access to the source code. So if you're reviewing a third-party application, inspect the page source to make sure that user input is encoded. So you can do this pretty easily by supplying inputs that you can find easily in the DOM, maybe 5 A's in a row followed by some special characters. Control F for those 5 A's in a row in the DOM and see if those special characters show up exactly as you input them, or if they've been replaced by things like ampersand, GT, and the entity encoding that you would see for an HTML page. If you see them not being encoding, that's a good chance that you might have unencoded input reaching the page, and you should test that. Tamper with all the URL parameters and form fields that you can find, and create objects with attack payloads. So in this case, if you're testing a Salesforce application, create account names, things like that, that are going to have special characters in them so you can see if they're getting rendered on the page later. This works great for black box testing. If you're doing white box testing, which means you do have access to the source code, there's a few great anti-patterns that you can look for. So escape equals false. You know that this is typically going to be dangerous because you're turning off escaping intentionally. So we definitely want to look at those and make sure you're handling that very carefully. Assigning directly to inner HTML and using the Aura unescaped HTML tags. So look for these things. Make sure that whatever you're putting into these tags is either not supplied by the user or you've already done the encoding manually before you've supplied it directly to those fields. And make sure all merge fields are escaped appropriately. So unless you're just sending it straight into HTML, which we know is going to be safe, almost every other place that you're injecting merge fields, you need to look and make sure that that data is being escaped appropriately. OK, now I'll hand it off to Jeff, and he will talk about SOQL injection.
All right. OK, so moving on then, SOQL injection. One of the first things when I talk to people about SOQL injection, if they're new to the Salesforce development, a lot of times they'll say, well, isn't it SQL? Aren't you pronouncing it incorrectly? And it's similar, but it's not exactly the same. So most people are familiar with SQL. It's a common language for database queries. You can see an example query there and the list of some of its features. SOQL is similar, but it's specifically for Salesforce objects. It's also a little bit more restrictive. It doesn't allow things like field wildcards. There's no facility for updating within a query. You have to do that within DML, within your application. These turn out to be really beneficial properties for security, and we'll talk about why a little bit down the road. As a result of those somewhat more limited more limited features, when we look at the impacts of injection flaws on SQL versus SOQL, the impacts are somewhat less. So in either case, we can modify the query to retrieve arbitrary data, through that query by manipulating it. In the case of SQL injection, we can also edit the database, so we can insert records. I might be able to do something like create an admin account for myself. On SOQL, I can't do that because there's no way to write to the database. So the point of this is that SQL injection has more impacts than SOQL injection, but it still gives you really significant access to the application. You can basically read anything from the database, whether or not you're intended to view that information. As Travis said, it's a little bit less common than cross-site scripting, but that does make it a really severe vulnerability. If you think about things like, if you're tracking sales leads, you might have forecast information that you don't want, everyone to have access to. So it's important to consider this. So looking at how queries are written, we've got an example here. And throughout this, the left side is SQL, the right side is SOQL. This first part is common to both. So we're just basically taking user input and creating a variable. We're putting the percent signs around there because they act as wildcards so that we have some fuzzy matching. We don't have to have exact string matches when we're searching. So in both cases, we do a select. Again, there's some minor differences. SOQL doesn't allow for the star wildcard, so you can't select all fields. You have to explicitly name each field that you're retrieving. And then instead of using a table name, we use the object name that we're retrieving. But otherwise, they're pretty similar to one another. But let's consider a case where I put in an input like this. So I supply my name, but then I add a percent sign, again, giving us that wildcard, and a single quote, which then closes that SQL statement. I add an or, so I'm appending a second condition to that SQL query. And then I say name like single quote. And so that's just going to open another string, and it's going to consume that percent sign and essentially become a wildcard. So what we have is a resulting query that looks like this. And you can see the red parts there are what I've supplied. But when the query is executed, it's not aware of what's user supplied and what's just part of the query string that was supplied, because the query string is concatenated with the user input prior to invoking the query. So that's really where the vulnerability arises from. So in the case of SQL, this is going to return a record of all columns in that table and all contact rows within that table. On the SOQL side, in this case, it's only going to return the ID and the name of all the contact objects. So again, because we don't have that wildcard in the select statement, the impact is a little bit lessened. But we could get around that with some craftier queries. But at least in this example, it limits the impact some. So I'm going to do a demo here. And again, this is from our recently released Trailhead. And there's a bunch of these that walk you through and give you some hands-on. Where is it? There we go. OK, so this example, throughout the Trailhead module, we have a theme of kind of a medieval environment. So you've got objects that are things like castles or knights or peasants and whatnot. So here we have a query that just lets us look people up who are in our village based on their title. So I can come here and say something like, search by title Sir, perform search, and it gives me everyone who has a title of Sir. And we see that they're all knights. So that's the intent of our query. If we take a look at the source here and see what's actually happening behind the scenes, we find this query. So we've got a query string, select name, role, title, age from personnel. And then we have this where clause string, which is currently blank. If there's a title attribute supplied from user input, then it's going to create a where clause that adds title C like textual title. So again, we have these wildcards, and we're just appending our string. Then it's going to actually query the database with the query where that where clause. So it's building up the query somewhat dynamically. And it returns that as where clause records. So from this example, you could probably see from the earlier slide where the injection comes in, and it's right here where it's appending the user supplied input. So going back, and again we talk about black box versus white box. It's nice to have the source. You can really see how it works. But if you didn't have the source, you might come along and just try something like Sir single quote. And if you do that, you get an error. And that's usually a pretty good indicator that you have something that's at least worth looking at to be potentially a SQL injection vulnerability. In this case, we've got pretty verbose errors that tell us the page is called SOQL injection and it's class SOQL injection. So we're seeing some back-end information about the structure of the application. If we take that a little bit further, we can query for other fields. So let's close this out again with a parentheses and a single quote, and we'll do and what is the let me see, what was the performance? So there's another field here that we don't see in this query.
Underscore.
Yeah, there's a field called performance rating. And I know that because I've seen it in other parts of the application. But the main point is that it's not visible here. We only have name, title, role, and age fields. But by closing out this query and adding this and performance rating, actually let's make it an or, because that'll be more urgent.
And then you can leave the name blank and it'll get everyone.
And then we're going to do less than 2. So we want all people that have low performance ratings. And then...
And name like...
Hang on. It's that...
And name like...
And name, yeah. I just need to make my query well-formed, so I add another wildcard. OK.
I think you take your name out at the beginning, too.
Take which name out?
The name out of you.
The sir? Yeah, because that'll give me more results. So if we execute that, we see nothing. That's not good.
You've got the copy-paste.
I've got some syntax problems. Whoa, that's not what I was looking for. Excuse me. Yeah, good idea. It's on, there it is. Cheat sheet to the rescue. So this is well-formed. It's a little tricky to get the syntax right on the fly. But basically, we're closing out the existing query, searching for the performance rating, and then joining it just to consume the trailing characters from the original query. And that's not working either. Did somebody patch our app?
I promise we tested this just before we got up here.
Yeah. This is not
Space
going
after
well.
the quote.
Space after which quote? Oh, after the and. That's the problem. Syntax errors. And I'm still not getting it. Why not?
You already fixed it?
No. I just looked at the source. The light.
Like at the end.
Like at the end.
And name like.
Yeah, because we've got the...
Yeah.
Thank you.
I thought you pasted it, sorry.
Winning. All right, so there you go. So we've got one record that satisfied our query. So we know, even though we can't see the result, that this person has a performance rating that's less than 2. So let's go back to the slides, and we'll talk about fixing this. That was pretty rough. OK, so mitigations. The first and best mitigation when you have a simple query that's operating on strings like this is to build that query with a bind variable. So I mentioned earlier that when we build queries from concatenating strings, on the back end when it's processing, it does that string concatenation and then runs the result as a query. So it's kind of a 2-step process. Here with a bind variable, the variable is treated as a variable in the query. So it's one operation, and the query can keep track of this as a variable and prevent it from escaping out of that context and supplying other conditions. So there's no means of escaping from this. It can be difficult for highly dynamic queries where you might be querying a different object or different fields of an object based on user input. But in the simple case where you have a static query and just a where clause, this is by far the best bet. For some of the more complex cases, you can do things like escape single quotes. So if you call this string escape single quotes method, it's going to replace that single quote with a literal escaped single quote. So it's not interpreted as a control character by the query and doesn't allow us to escape. But that doesn't work in all cases. That's really only good when we're talking about strings, because there's other types of queries where we might be able to provide malicious inputs that don't contain a single query, a single quote. So if we think about the query example on the screen here, what happens when we provide true and receives admin info emails equals true? There's no single quote within that string literal, but it's going to dramatically change the impact of the query and give us a list of only people that are, or only users that are both active and receive admin emails. So we've now determined who all our admins are. So again, when we use escape single quotes, we need to be a little bit careful about being in the appropriate context and making sure that that mitigates all modifications that can occur to that query. There's other mitigations as well. Typecasting is a good one if you have an input that's not a string. Like let's say it's an integer or maybe it's a date. And so we know that by nature of being an integer, it's never going to have a single quote in it, and it shouldn't be invalid. So we'll just take the string that the user provided as input and cast it to an integer. And we do this by calling the string value of function. Then we have an integer. If it's a wrong type, that conversion fails. So it'll still provide an error in some cases, but it doesn't allow us to manipulate that query. And then the last mitigation that we're going to talk about is the bottom here, character replacement. Now this one you have to be really careful with. Basically what we're doing is we're looking through for any character that doesn't match the regex for word characters. So if we have a single quote, something like that, it's going to just replace it with an empty string. So it's going to remove it from the string. But this can be dangerous if we don't consider all the characters. If our match doesn't consider all cases that can manipulate that query, we might miss things. There's also cases where we might make changes to the string that we didn't intend. Let's say that we have someone who has a last name that has a single quote in it, or an apostrophe or whatever. We don't want to modify that person's last name in the name of security. So this is kind of a when all else fails, and it's one that I mostly include for the sake of completeness. It's really not something that we want to consider as our primary and first defense. So let's go back to the demo and fix it. Where is my... And hopefully I can fix it better than I can break it today. So let's go into our controller code, and we're going to edit. We talked about where the vuln was before, and it's right there on that where clause where we're concatenating strings. So that's actually my cheat sheet down there. I'm going to comment this out, and we'll just rewrite the query entirely, because that turns out to be a little easier in this case. So the return value here is going to be where clause records as a list. So let's return that. And before we do that, we need to handle our input. So let's create a new string, and we'll just call it Q title, right? And what I'm going to do here is assign the wildcard. So this is just basically concatenating our title to two parentheses so that we have those fuzzy matches on the side. What we're going to do here is we're going to change our query syntax, and we're going to use a bind variable. So we'll do pretty much the same query: select name, role C, title C, age C, from personnel.
Age.
What did I get? Oh, thank you. Syntax is hard. From personnel C, and we'll add where. What was it? Text. Let's see. It was where title. Is it title?
Next line down.
Title C. Yeah. Title C, like, and then we'll put in a colon and our Q title record value. All right. So that's a bind query, and it's gonna have the same effect. It's essentially the same query. But by using this syntax and inserting this as a bind variable, the query engine's able to tell that that's a bind variable. And I need a semicolon. So let's save that. And I'm missing a semicolon. What did I do wrong? Line 12, column 15.
Another plus.
Plus, thank you. All right, so that one's saved. So let's go back to the demo, and I'm just going to reload. So let's try our regular query just to make sure things still work. Sir still works. Sir single quote no longer returns an error. And let's try the big. Well, I didn't have sir on that one, did I? I was just performance rating and name like. That's the one. And so we can see that those queries no longer return unexpected data. So that's fixed. All right, so summary. you want to do the cross-site scripting, or should I?
Sure. So in summary, make sure you're always aware of the context that you're rendering your data in. If you're in JavaScript, make sure you're using JS encode. If you're inserting into JavaScript and then also into HTML, which is very rare, but usually in cases like when we demoed, if you're assigning to inner HTML directly, that's the kind of case that you'll see it. Use JS and HTML encode there. Reminder that Apex output text is always going to be safe. And same thing for the HTML context in Visual Force. Both of those are safe by default.
OK. And on the SOQL side, prepared statements, those bind variables, that's our best bet in the common case. So you want that to be your go-to pattern for writing queries, unless you have needs that don't fit that type of query, in which case you have other options, but you need to be careful. Whitelisting is great for dynamic queries where you have known values. So if you only have 10 possible choices that a user can select from, make sure that it's one of those 10 choices. Or we mentioned, if you're expecting an integer, just cast it to an integer. Escape single quotes. Again, that's one to be a little bit more careful with. Typecasting. Yeah, I kind of mentioned that on whitelisting. So that's really all we have. We don't have any time for questions. We're kind of a little bit long, but we're going to head over to the booth again in the developer forest, back by the big tree. So if anyone has any questions or wants to talk more about security, we'll both be there, and some other members of our team. So thank you all for coming by.